Let's go for task number 6. A random experiment was conducted where person A tossed 4 coins and recorded the number of heads. Person B rolled 2 dice and recorded the number of smaller number out of the 2 dice. Simulate this scenario, use 10,000 long columns and answer the questions. Okay, here I have come up with tables for the probability of a dice when a die is rolled and probability table for when a coin is tossed. So 1, 2, 3, 4, 5, 6 is the number of faces. 0 and 1 represents head and tail. So let 1 be head and 0 be tail. So now let's first go for tossing 4 coins. So that means we would go for random number generation, data analysis, random number generation, click on OK. So let's go for discrete, and we are going for 4 variables. Since 4 coins were tossed in an instant, so we go for that. And here we need to go for 10,000. So total number of random numbers is 10,000, and discrete is the distribution. So for probability and input range, we go for the 4. Okay, click on OK. Then in a new worksheet, this one is for dice. Sorry, 4 coins. Person rolled 2 dice. Let's go for 2 dice. So data analysis, click on OK, random number generator. We need 2 dice. 10,000 is the total number of random numbers. Discrete, and this one value and probability input range is from A2 up to B7. Okay, click on OK. Now we shall get 2 columns of data, and this is dice, 2 dice. Okay, and you can see that if you hold Control key and down arrow, then you can get 10,000 data. Now let's read the question. Here it says, in order to toss a coin, one must make a coin in Excel. That's fine. Here we did all the things. Okay, use random number generator to discrete distribution and blah blah blah. For coins, first simulated 4 columns, then create 5th by writing the sum. So let's take the sum of 4 columns of coins. Okay, in column E equals sum from A1 up to D1. Okay, then hover on the right bottom and click. So then you should get all the 10,000 sums. Okay, so column E is the sum. For dice, first simulate 2 dice and then create 3rd column by writing minimum equals minimum A1 B1. Okay, so for dice we go for minimum. So this is equal minimum of these 2. Thus we get all of these things. Okay, so minimum and maximum. Okay, so here it is clearly saying that create a histogram with pins 0, 1, 2, 3, 4, 5, 6. So let's go for that. So let's go for 2 dice. Let's go for 4 coins at first, and 0, 1, 2, 3, 4, 5, 6. Okay, so that's fine. So that's the bins for 4 coins. For 2 dice, for the minimum of 2 dice, we go for 0, 1, 2, 3, 4, 5, 6. Okay, so these are the bins for minimum, and for 4 coins, these are the bins for the sum. Okay, now let's go for 4 coins at first. Go to data analysis, histogram, click on OK. The input range is E1 up to E10,000. Okay, so that's it, and the bin range is simply F1 up to F7. Alright, click on OK. Then in worksheet number 4, histogram for coins, we have this thing. So 0 sum, that is 582, and you can see other things also. For sum 3, there are 2480, and 4, 692, 5 and 6 are 0. Okay, that's fine. Now let's draw histogram. Okay, so select this, click on insert, and recommended charts, go for this one, click on OK. Alright, so this is the histogram. Okay, so we are done for coins. Now let's go for dice. So let's go for data analysis, histogram, click on OK. Here it is the minimum is in column C, so let us replace this E by C, and that's C 10,000, and this one is, delete this one, so D1 up to D7. Okay, click on OK. So we get this as our table. Select the table, then everything is covered. Okay, okay, insert and recommended charts, so go for this one, so click on OK. So you can see that this is kind of different. Okay, one is the minimum, that's quite apparent. All right, now here it says that which of the two people, A or B, is more likely to get number 1. For 2 dice, the people rolling, for the person rolling 2 dice, that person gets 3,552 and 2,530 for the person who tosses 4 coins. Okay, so clearly person B, the person who rolls dice, will get that. Okay, so B is the person, right? Yeah. Okay, all right, that's good. Which of the two people will on average get a higher number? Which of the two people on average get a higher number? Then you can see that for this one, for 4 coins, the higher number, the average is 2.0, and for 2 dice, the higher number is 2.55. So it's quite apparent that person B will be getting the highest number. Okay, so that's fine. What is the probability that a person A obtains number 5 or 6? 5 or 6 means either 5 or 6. Okay, so for coins, yeah, either 5 or 6 means these two. So there is no possibility that they will get 5 or 6. Okay, and you know the reason why. Which of the following people have the higher probability of getting number 3 or larger? Number 3 or larger. Okay, so that means we can for person A, it's 2480 plus 692, so that is equal sum these two, 2480 plus 692 divided by 1000 or divided by 10,000, so that's 0.3172, and for 2 dice, 3 or higher. Okay, so this is the sum, so equals sum 3 and higher means up to this one, so divided by 10,000, yeah, so 4545, so higher probability of B. Binomial distribution and the Bell-shaped curve. The very idea of distribution is a tricky one to explain. The concept is hard to grasp. Even students taking higher level math courses often struggle with it. Luckily in this class we have made some experiments and developed some intuition. Remember the simulations and always we told the computer to roll a die. We actually had to make the table consisting of outcomes of the experiment and the probabilities. Okay. Well, this is a perfect example of distribution. It is a recipe we use to describe a random experiment. So distribution is the method that we describe a random experiment. Let us revisit some random experiments we have performed already. Sum of 5 coins experiment. Here we must be careful. Although these experiments consist of 5 smaller experiments tossing 5 coins, we focus our attention only on the number of heads after 5 coins were tossed. Right? That means getting number of heads. Getting heads would be our success, and getting tail will be the failure. That and only that is what we consider the outcome of this experiment. So we only consider the outcome to be head. Okay. So let us try to describe the distribution of this experiment. So outcomes are 0, 1, 2, 3, 4, 5. So when you toss 5 coins at once, then possibility of getting head is either 0, 1, 2, 3, 4 or 5. Okay. That was easy. When we count the number of heads on 5 coins, 0, 1, 2, 3, 4, 5 heads. No less, no more. Now we have the harder question. How about probabilities? Well, for this there is a formula Px equals to K. X is the variable and K means the total number of success. Success is getting heads in this case. Okay, equals, this is n choose K. This expression n choose K is known as binomial coefficient. Okay, and there are n number of observations. That means the outcomes can happen in n number of ways, and we choose exactly K times. Okay, so kth, the choice is K. So P to the K means P is the probability of getting success. Here in this case, probability of getting head is 0.5, and 1 minus P is failure. Okay, getting tail. Okay, n minus K. So where n choose K is defined by n factorial divided by K factorial, n minus K factorial. So factorial means you multiply up to the first natural numbers. Okay, so if there is 5 factorial, then we multiply 1, 2, 3, 4 and 5. An example will help. In our case, X is the experiment. The number of heads after 5 coins were tossed, n equals 5. Since we have 5 coins, and P equals 1/2 is the probability of success getting head, okay, which is 0.5 or 1/2. And K is the number of heads, how many heads that you want to get. So plug this in this formula. Okay, finally the mathematical formula, P X equals to K, translate into English the probability that the number of heads equals to K. So how many times would you like to get head? So K times. Okay, so that's the probability of getting K heads. Okay, using the formula is quite easy. Say we want to find the probability that the number of heads equals 3. According to the above little tutorial, Px equals 3 means you plug in 3 in here. Okay, and then n is 5. Okay, since there are the highest number of outcome is 5, and so 5 choose 3, 0.5 whole cube, that means 1/2 of cube, 1 minus 0.5 to the power 5 minus 3, that's n minus K. Thus we get this one, 10 as our thus 5 choose 3 is 10, and this expression is 132. So that becomes the probability of outcome 3 is equal to 10 over 32. Okay, with this we can now describe the recipe, the distribution of this experiment. So getting 0 has probability 132, getting 1 has probability 532, 5 by 32, 2, 10 by 32, 3, 10 by 32, 4 by 4, 5 by 32, and 5, 1 by 32. So these are the probabilities and these are the possible outcomes. Okay, okay, so no problem, we'll talk about this in the class. Since Excel has a nice way to perform the binomial experiment, so no need to go for combine 5, 3 and so on. This particular distribution is known as binomial distribution, and it is used in following types of setups. X is number of successful outcomes after performing n smaller experiments where each of these smaller experiments is performed independently and each has probability of success equals P. In our cases, we have 5 coins and success was getting H. P was obviously half. Okay, let's go for task 7. Let X be the experiment that counts number 6 after 7 dice were rolled. So we want 6 as our success. So when 7 dice were rolled, then number of times that we can get 6 would be 0. That means out of those 7 dice, we may not get any 6. Okay, we can get 1 for 2 times, for 3 times, 4 times, 5 times, 6 times, and 7 times. Okay, so these are the possible outcomes. What are the n and p in this case? Okay, n is equals to 7 is the probability is 1/6, right? Since there are 6 faces and we want the particular one face, that is 6, face of 6. N equals to 7 since we rolled 7 dice, and p equals to 1/6 since success in this case is getting 6, which has probability of 1/6. What is the probability of having 2 as an outcome? Okay, probability of having 2 means we are wanting 2, 6 as our outcome. Then without going through this formula, we will just go to Excel and type this thing. Okay, so the formula is equal binom dist distribution and number of successes that you want. Okay, so here it is written number s, that means number of successes, that is 2. Okay, number of successes is 2. And trials, so how many successes are possible. So let's type this formula in Excel, which is equal binom dot dist distribution, and so number s means number of success that we want. Here it is 2, that means we want 2 6s out of 7 die roll. Okay, comma trials is how many possibilities are there. So there are 7 possibilities. Okay, so the highest number of possibilities is 7, so let's go for 7. And probability of s, probability of success is 1/6, 1 divided by 6, or we can just write down this one as our probability of success, comma cumulative distribution is false. Okay, please write down false for exact probability of getting 2 successes. Okay, so that's 0.234429. Thus, rather going through this lengthy calculation, we just use Excel, okay, and get the same thing. Okay, now bell-shaped curve. Surprisingly, if one were to plot these probabilities for each of those numbers, each of these 8 numbers, then we would be getting these kinds of things. Okay, so getting 0 would be nearly 0.3. Getting probability of getting 1 success is nearly 0.4. 2 success 0.2344, 3 nearly 0.1, and so on. Okay, and for n equals to 12, that means if you go for okay, so this is the case for this problem that we did for task 7. And now let us suppose there is a case where we have the total possibility of successes is n equals to 12, and the probability of getting that success is 1/4. Then we might get this kind of distribution. Okay, and similarly we can get this kind of distribution for n equals to 12 and p equals to 1/4. Okay, so all of these cases boils down to left skewed distribution. Okay, so that's all, and please go to the PowerPoint that I have posted online about binomial distribution, which I'll be talking about slightly later on.